Unlocking the mysteries of fractal geometry. Hello everyone, welcome to our educational channel. Today, we're going to dive into a fascinating and visually stunning area of mathematics, fractal geometry. This concept may sound complex, but don't worry, we'll explore it step by step. By the end of this video, you'll have a clearer understanding of what fractals are and why they're so important in both mathematics and the natural world. Fractal geometry is a field of mathematics that studies shapes and patterns called fractals. Unlike regular geometric shapes like circles and squares, fractals have unique properties. The most striking feature of a fractal is that it is self-similar. This means that if you zoom in on a part of a fractal, you'll find smaller versions of the whole shape. It's like a never-ending pattern. Fractals are not just theoretical concepts. They appear in nature, art, and even in computer science. Fractals are fascinating because they possess some unusual characteristics. Firstly, they have infinite complexity, meaning the more you zoom in, the more details you see, without ever finding an end. Secondly, they exhibit scaling symmetry or self-similarity, as mentioned earlier. This symmetry is what makes fractals both mystifying and beautiful. Lastly, fractals often have a fractional dimension. Unlike the dimensions we are used to, like the 2D surface of a paper or the 3D space of a room, fractals exist in between these conventional dimensions. To help you visualize fractals, let's look at some examples. One of the most famous fractals is the Mandelbrot set, a complex and mesmerizing pattern created using a mathematical formula. In nature, fractals can be seen in snowflakes, tree branching, and coastlines. These natural fractals show how the concept of self-similarity applies to real-world objects. Fractal geometry is not just a theoretical concept. It has practical applications in various fields. In computer graphics, fractals help in creating realistic landscapes and textures. In science, fractals are used to model complex structures like the branching of blood vessels and the formation of galaxies. Understanding fractals also helps in studying and predicting patterns in weather systems and financial markets. Thank you for joining us in this exploration of fractal geometry. We hope you found this journey through the intricate and beautiful world of fractals enlightening. Remember, fractals are a perfect example of how mathematics can be both fascinating and applicable to the real world. Stay curious, and keep exploring the wonders of mathematics.